Out there in the colossal absence of lucidity of room, the James Webb Space Telescope has been exploring the littlest things for replies about the universe. This NASA's new eye above has been tracking down stunning pictures of stars, monstrous planets, and planets. Finally, something disturbing has been found. Something so gigantic it could shake the genuine spines of all that we figure out. It has researchers scratching their heads and investigating whether it could touch off the farthest fundamental of everything. Go close by us as we inspect how the most recent disclosures of the James Webb Space Telescope could crush our comprehension of the universe. When we investigate the edge of the universe, we are discussing the recognizable universe. The noticeable universe radiates an impression of being a window through which we can take a gander at the degree past the detectable universe. It incorporates all that we can as of now see, measure, and research using our telescopes and space tests. It's a course of action of stars, frameworks, and cosmic bodies within our grip of finding. Regardless, the detectable universe is a tiny bit of the whole universe. Envision it as a cut from a colossal pie that we're prepared to study and handle. While the absolute size and state of the universe overall remain a secret, researchers gauge the width of our noticeable air pocket to be around 93 billion light-years. A light-year measures the distance that light, the quickest thing in the world, goes in 1 year around 5.88 trillion miles or 9.46 trillion kilometers. So, when we discuss the expansiveness of the distinguishable universe being 93 billion light-years, we're examining an epic stretch. Around 13.8 billion years ago, the universe burst into reality in an unimaginably solid effect. This occasion begun what we call the Big Bang. Since that titanic birth, the universe hasn't just been fostering, it's been advancing quickly in its development. Puzzling powers, like the unusual dark energy, which gave off an impression of being driving the speed increment, have been further isolating the limits of the universe as it loosened up. Matter began to assemble, influenced by gravity. This gravitational power joined particles, birthing shocking plans. Stars, huge frameworks, and in the long run planets like our own Earth. Picture the universe passing by as these colossal structures formed, shaping into the excellent yet continually advancing characteristics we see across the universe today. Regardless of its immense size, the universe is staggeringly void. On the off chance that we somehow wind up pulling back our whole planet to the size of a quarter, the closest star would in any case be about the length of 2 soccer fields away. This limitless quality enlarges right inside our own Milky Way galaxy, which is only one among billions in the apparent universe, outfitting us with a sensation of the sheer size of unfathomable space. Now, you could inquire as to why we can't fundamentally see all that exists in the universe. There are a few explanations for this limitation, mostly involving light, the fastest thing known to man, which still takes time to go through space. This suggests that when we take a gander at far-off objects, we are essentially zeroing in on the past. The farther an object is, the more time its light has taken to contact us. It's like glancing through a titanic time machine, unrolling the historical past of our universe. As we notice frameworks millions or even billions of light-years away, the universe is widening. Envision spots on the outer layer of a creating inflatable. As the inflatable extends, the spots move farther separated. This same rule applies to the universe. Galaxies, like those spots, are floating separated as the outer layer of space extends. This expansion causes the light from a long way away objects to go through a shift known as redshift. Basically, the frequencies of light stretch as the particles move away, pushing toward longer frequencies, typically giving off an impression of being bronzed in variety. Given these variables, light's development time, the expansion of room, and the universe's steady augmentation, it's not astonishing that we haven't yet totally seen all that the universe offers. Even with our especially high-level telescopes and innovation, our view is still limited by these fundamental properties of the universe. The journey to understand the possible edge or limits of the universe has intrigued the minds of many people across disciplines. While undeniable responses remain perilous, 3 unmistakable speculations have arisen, each offering interesting points of view on the expansion of limitless space. The first hypothesis suggests that the universe develops enormously, continuing perpetually without a detectable edge. This thought lines up with the cosmological principle, which states the isotropy of the universe, that it appears to be consistent from any vantage point. Assuming this is true, it suggests that the universe comes up short on limit and extends vastly toward each heading. The second hypothesis offers an elective view, suggesting that while the universe may indeed be limited, it comes up short on clear edge. Maybe it could look like a colossal circle or a wound space like Earth. In this situation, if one somehow managed to travel perpetually toward any course, they would ultimately get back to their starting point, like circumnavigating Earth. The third hypothesis, the multiverse theory, presents an intriguing thought that our universe is only one of an infinite number of others. Envision a boundless number of parallel universes, each existing with its own arrangement of physical regulations, constants, and properties. These universes might be very surprising from each other, working autonomously, or they might be interconnected through complex frameworks, forming a huge and astounding multiverse. The James Webb Space Telescope, JWST, remains as a badge of potential, elucidating the secrets that lie at the enormous beginnings of the universe. This incomprehensible instrument has an unrivaled ability to release the bewildering past of our universe, permitting us to peer a long way beyond what was beforehand conceivable. The JWST is a mechanical wonder, designed explicitly to observe the universe with striking exactness. Its high-level capacities stretch our vision to the earliest snapshots of the universe. A pivotal report published in the esteemed journal Nature revealed the JWST's discovery of 6 monstrous galaxies, dating back between 500 million and 700 million years after the Big Bang. Awesomely, these old galaxies are far larger than anticipated for their early presence, challenging prevailing hypotheses of galaxy formation. Moreover, their development in the early universe is truly surprising. What's remarkable about these discoveries is the degree of intricacy in these old systems. This goes against the assumption that galaxies form slowly over time. These enormous galaxies show a degree of complexity equal to our 13-billion-year-old Milky Way galaxy. The sheer number of stars inside these titanic behemoths surpasses our expectations, with each galaxy boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies may even have a mass up to a few times that of our Sun, eclipsing the already enormous size of our Milky Way. The JWST's unmatched capacity to research the universe's mystery spaces relies on its utilization of infrared light, an undetectable range to the unaided eye. This amazing power enables the telescope to capture the weak emissions from old stars and galaxies, revealing vast remnants that have persevered for billions of years. Basically, the JWST acts as a time machine, moving our vision back through the ages and offering a charming look into the universe as it appeared over 13.5 billion years ago. The continuous discovery of gigantic galaxies, rigidly nicknamed universe breakers, has changed our understanding. It's like reworking history, a dazzling twist that challenges many of the models we had laid out for early galaxies. Initially, we believed galaxies formed from humble beginnings, starting as small collections of stars and dust. They were thought to slowly evolve over time, growing in size and complexity. However, the universe breakers have shattered these ideas. When the JWST data and its high-resolution images revealed these enormous structures, they appeared seemingly out of nowhere, as if they had just been discovered, astounding our past comprehension of vast development. Digging deeper, investigators used spectroscopic techniques to analyze light across different frequencies. This examination holds the key to unlocking crucial insights about these baffling galaxies, such as their structure, size, and distance from Earth. It's like a tremendous investigative story, with light as the key to uncovering the secrets of these huge entities. The shocking revelations from the James Webb Space Telescope have changed our understanding of the universe to exceptional levels. This cutting-edge telescope, built by a global team of space researchers, has recently unveiled a stunning discovery: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to when the universe was just a small part of its ongoing age, existing only a short time after the Big Bang. The James Webb Space Telescope, out in the vast darkness of space, has been looking for answers about the universe. It's NASA's latest powerful instrument, capturing stunning pictures of stars, galaxies, and planets. Recently, It made a discovery so phenomenal that it could change how we comprehend the very fabric of the universe, leaving specialists surprised and curious about its true potential implications. When we study the universe, we begin with the observable universe, a window into the infinity beyond. This visible universe encompasses all that we can currently interact with through our telescopes and space probes, including stars, planets, and other celestial bodies. However, it's just a small part of the entire universe. Researchers estimate the width of our observable universe to be around 93 billion light-years. A light-year measures the distance light travels in 1 year, around 588 trillion miles, making the range nearly infinite. About 13.8 billion years ago, the universe began with the Big Bang, a gigantic blast that set off the incredible expansion. Since then, the universe has been stretching and accelerating, driven by mysterious forces like dark energy. Matter began to come together under gravity, forming stars, galaxies, and eventually planets like Earth. This continuous process shapes the universe's vast size, allowing us to observe only a tiny piece of its endless complexity. Indeed, even with this expansion, much of the universe remains dark and empty. Despite how far we've come in exploring space, much of it remains hidden. Even with the power of the James Webb Space Telescope, large portions of the universe remain far off. Yet, its discoveries continue to reshape our perception, offering a glimpse into the incredible wonders that lie just beyond our sight. The infinity of space continues to stun and inspire. However, with each astounding observation, we are slowly piecing together an increasingly complex understanding of the universe's history and future. The James Webb Space Telescope is an instrument that could forever impact the way we think about space, time, and the very nature of our reality. The repercussions of the JWST's discoveries extend beyond academic theories. They challenge the very foundations of modern cosmology. If these giant galaxies existed so early in the universe's history, it leads us to reconsider current models of galaxy development. For decades, scientists have adhered to the idea that galaxies develop slowly, starting as small, dense collections of gas and dust, steadily advancing over billions of years. The discovery of these enormous galaxies, formed within the first few 100 million years after the Big Bang, presents a mystery that doesn't align with this gradual development. This discovery raises new questions about the nature of galaxy formation itself. How did such large, complex galaxies form so quickly after the universe's beginning? What forces were at play in those early times that enabled rapid star formation and the development of galaxies on a massive scale? These questions don't just challenge our current understanding of the early universe. They also stretch the boundaries of our knowledge of physics, particularly regarding the behavior of dark matter and dark energy during the universe's infancy.